In this video, we will talk about variations of sine and cosine functions y equals a sine of x and y equals a cosine of x. Before we start, we will quickly review the graphs of the basic sine and cosine functions because they will help us better understand the variations of these two functions. I will start by graphing y equals sine of x. So here we have the graph, and the maximum value of this function is 1 and the minimum value is -1. The amplitude of this function is 1, and this represents the maximum value of this function. The period of this function is 2 pi, and this means that the function repeats itself every 2 pi units. Also notice that the sine function passes through the origin. Next, I will graph the cosine function. Here we have the graph, and just like with the sine function, the maximum value is 1 and the minimum value is -1. Also, the amplitude of the cosine function is 1 and the period is 2 pi. So they both have the same amplitude and period, but the cosine function crosses the y-axis at 1. Now, once we have these two basic functions, let's talk about the variations y equals a sine of x and y equals a cosine of x. The sine and cosine functions of this form will have the same period as the basic sine and cosine functions. However, because of this number a that we have in front of sine and cosine, these functions will stretch or will shrink vertically. The amplitude of these functions will depend on this number a, and we will find it by taking the absolute value of this number. So if this number a can be positive or negative, the amplitude will always be positive. So if we have the function y equals 2 sine of x, then we can say that the amplitude of this function is 2. The period is 2 pi, and the only difference between these two graphs is that this one will stretch up to +2 and then down to -2. So then let's see the graph. And here we have it, and the highest value of the function is 2 and the lowest is -2. Now, what if we have the function y equals -3 sine of x? So the number that we have in front of sine is -3, but because the amplitude is the absolute value of this number, absolute value of -3 is +3. So the amplitude is +3. The period of this function is still 2 pi. However, because of this negative that we have in front of the function, the graph will be reflected about the x-axis. So let's see the graph. So the graph still passes through the origin, and the highest value is 3 and the lowest is -3. However, because of this negative that we have in front of the function, from the origin, instead of going up, we need to go down. So with the sine function, if in front of sine we have a positive number, from the origin, first we move up. But if in front of sine we have a negative number, from the origin we will go down. Now let's see the function y equals 1/2 cosine of x. Here, because of this number in front of cosine, we can say that the amplitude of this function is 1/2. The period of this function is 2 pi, just like the period of the basic cosine function. And now let's see the graph. Now, if we compare these two graphs, we see that this one crosses the y-axis at 1, but this one crosses the y-axis at 1/2. So here the highest value of the function is 1/2 and the lowest is -1/2. Now let's see one more example, and this will be y equals -4 cosine of x. The amplitude of this function will be positive 4 because the amplitude is always represented by a positive number. However, because of this negative, the function will be reflected about the x-axis. So if in the function y equals 1 cosine of x, the graph crosses the y-axis at 1, and in the function y equals 1/2 cosine of x, the graph crosses the y-axis at 1/2, then in this function, the graph will cross the y-axis at -4. Now let's see the graph. So here we have it, and as you see, it passes the y-axis at -4, and the highest value is +4. In these 4 examples, I wanted to show you how these graphs compare to the basic sine and cosine functions. They all have the same period of 2 pi, and only the amplitude changes depending on the number we have in front of sine or in front of cosine. Also notice that for each of these graphs, I had 5 points that I connected to form the graph. So I want to show you one more example where we will graph a function on the period from 0 to 2 pi, and I will show you how to get the amplitude and the coordinates of these 5 points. The function that we will graph will be y equals -4 sine of x. The amplitude of this function is the absolute value of -4. So we will write that the amplitude is the absolute value of -4, which is +4. This means that the highest value of this function is 4. The period is equal to 2 pi. To the right, I will start the rectangular coordinate system. And on the y-axis, I will plot 4 units up and 4 units down. I will graph this function over the period of 2 pi, so on the x-axis, let's have 2 pi. Now to find the coordinates of those 5 points described above, we will take this interval from 0 to 2 pi and we will divide it into 4 sub-intervals. So then, if we take the period and we divide it by 4, that will be 2 pi divided by 4, which is pi over 2. So then, the length of each of these sub-intervals is pi over 2. Next, we have to find the x-coordinates of all these points starting with 0 and ending with 2 pi. They will also be the x-coordinates of those 5 points on the graph. The first x-coordinate will be 0, and to the left I will start a table that will hold the x and the y coordinates of those 5 points. Here in the first column we will have x, and the first value will be 0. To find the x-coordinate of the next point, we need to take the previous value and add a quarter period, which is pi over 2. Then 0 plus pi over 2 is pi over 2. So I will also add this to the graph. And now to find the next x-coordinate, we take the previous one, which is pi over 2, and we add a quarter period, which is also pi over 2. Then pi over 2 plus another pi over 2 is pi. And to the right, I will also add it to the graph. Now to get the next coordinate, we take pi and we add pi over 2, which will give us 3 pi over 2. So let's add this to the table, 3 pi over 2, and also to the graph. And now the last value that we will need to graph this function over one period is 2 pi, and we will add this to the table. So this was the first step in graphing this function. We took the period, we divided it by 4, and we got pi over 2. Then we found the x-coordinates of the 5 points. In the next step, we will find the y-coordinates of these points. From the previous examples, we know that if we have a sine function passes through the origin. Also, if we have a negative number in front, then from the origin, the graph will go down first. Then we can say that the y-coordinates will be 0, then negative 4, then again 0, then positive 4, then again 0. Another way of finding the y-coordinates is to take each of these x-coordinates and replace them in the function. For example, when x is 0, y equals negative 4 sine of 0, which equals 0. To evaluate this, we can either use a calculator, and we have to make sure it is in the radian mode, or we can use the unit circle. Here, sine of 0 is 0, and 0 times negative 4 is 0. So then, in the table, when x is 0, y is also 0. To find the y-coordinate when x is pi over 2, we will have negative 4 times sine of pi over 2, and this will be equal to negative 4. And this is because sine of pi over 2 is 1, and 1 times negative 4 is negative 4. So then in the table we will write negative 4, and now we will move to the next row. When x is pi, y will be equal to negative 4 sine of pi. This will be equal to 0 because sine of pi is 0, and 0 times negative 4 is 0. In the next row, y equals negative 4 sine of 3 pi over 2. This will be equal to positive 4, and that is because sine of 3 pi over 2 is negative 1, and negative 1 times negative 4 is positive 4. And now in the last row, y equals negative 4 sine of 2 pi, and this will be equal to 0. Sine of 2 pi is 0, and 0 times negative 4 is 0. So now we have the coordinates of all 5 points, and we will start plotting one by one. The first one is 0, 0, and that is the origin. The next one is pi over 2 and negative 4, so from pi over 2 we will go down negative 4. The next one is pi 0, then the next one is 3 pi over 2 and up 4, and the last one is 2 pi 0. Now what is left is to connect these points and form the graph. So then, here we have the graph of y equals negative 4 sine of x. I hope you enjoyed this video. Please subscribe, leave a comment, and thank you for watching.